Okay. Good evening. Can you hear me? Can you hear me? Okay. Uh, Today we're going to start our main physics lesson. Actually, the most advanced and very important physics lesson. It is electricity. Okay. Before that, I will explain how many physics lessons in our syllabus. How many physics lessons? We have 8 physics lessons. No? 8 physics lessons. No, 7. Only 7. Yeah, 7. What is the first one? The measurements. Okay, this why we discuss mainly with much about this physics part, because in exam paper, considerable component is physics. In MCQ part, 13 questions. In structured essay part, 2 questions, and essay part you can select. If you want, you can only answer one physics question. However, at least you have to answer for one physics question. Okay, therefore main component of the exam paper is physics. Okay, the second lesson, forces. Third lesson, work energy. Fourth lesson, mechanical properties. Fifth lesson, rotational motion. Fifth lesson, rotational motion. Sixth one, we have eight lessons, not 7, 8 lessons. Sixth one, heat lesson, heat energy, that we already discussed. Heat energy. Okay, measurement, forces, work energy, power, mechanical properties of matters, and rotational motion, as well as heat lesson already completed. Okay, 6 lessons completed. We have another 2 main lessons. We have another 2 lessons on the lesson 7, electricity. Uh, Final one, fluid mechanism. Okay, they are the physics lessons. Okay, now out of these 8 lessons, 6 lessons already completed, fully completed with all practice questions, and completely done 6 lessons. Okay, today we're going to start our last 2 physics lesson. It is electricity. It's electricity. Okay, after that, after electricity, we can start fluid. Before fluid mechanism, it's a very simple and small lesson that we can discuss later. Before that, I hope to discuss the chemistry part mainly from next month. Okay, my target complete everything in electricity lesson at least within 6 weeks. Okay, after that, we're going to discuss natural products, industry chemistry. They are very short lessons. We can quickly complete before May, within May or within April. If we can complete everything in our syllabus, we can discuss more questions, more papers in final 3 months. Final 3 months. We have enough time, no? Okay, therefore, this time you should have a target, not only this subject, even in other subject also. Complete everything, complete every syllabus, maximum 90%, maximum 90%, minimum 90% of the syllabus before April, before New Year break. At least 90% you have to cover. If not, you are trouble. At least within end of April end with the, if you can cover 90% of all syllabus, all subject, all 3 subject, then you can ready for the exam. Then you have another 100 days. After April, you have another 100 days. You can use the this 100-day very effectively, very efficiently, if you cover at least 90% new all subject before the end of the April, before the end of the April. Okay. Okay. Before that, are you got tooth pack? Not yet, I think. Anyone got? No tooths, no? Kabir? Not yet. Okay. Tomorrow morning you can get the tooth. Actually, it's not a one tooth, it's a tooth pack with all questions I have posted. Okay, you can get it tomorrow morning. Tomorrow morning, take the post office. You can find the tooth. Okay. However, I'm going to explain very basic things of the electricity lesson today. Very basic things. No need tools to understand. Very basic things we discussed. How electric current is forming and how to electric current is flowing. Flow වෙන්නේ කොහොමද කියලා අපි, that's the target of today lesson. Okay, today I'm going to stop the class at 8:30 or after our basic parts. Before today 31st, today is the final day of this year, no? Okay, tomorrow is a new year, 2026. Actually, before, more than it's new year, it's a new, you can take it as a new start, no? That's a very important thing. Take it as a new start. Everything start again newly, because 2026 is the your it's very important year of your life. Okay, therefore don't take it easy, this exam. Okay, electricity. Okay, this is your tube. Today you don't need this tube. I will explain the basic of the electricity. How this current is flowing through these conductors. Okay. Now, you already know molecules. In biomolecule lesson, I explained this, every type of molecules formed by electron, proton, and neutrons, right? Electrons, proton, and neutron that we already discussed in the biomolecule lesson. Neutrons and protons, they are located in the nucleus. Nucleus. This is the nucleus. Neutrons and protons, they are located in the nucleus. Neutrons and protons. Around the nucleus, they we called as energy levels or orbitals. Energy levels or orbitals. Energy levels. Okay, electrons locate in these orbitals, energy levels. Okay, in the biomolecule lesson, I told what is the charge of the proton. Is it positive charge or negative charge? Negative. Protons, not proteins. Okay. Protons. Is it positive charge or negative charge? Protons. Protons. Yes, very good. Protons are positive charge and neutrons are neutral. Yes. Neutrons neutral. No any positive or negative charge. But electrons are negative charge, minus charge, negative charge. Now, due to this positive charge and neutrons are neutral, then we called overall nucleus, it is positive charge. Overall nucleus is positive charge. Overall nucleus positive charge that we already discussed. Now, how about the charge of electrons? Electrons are negative charge. Electrons negative charge, therefore this negative electrons has an attraction to this nucleus. They have attraction to this nucleus. They have attraction to this nucleus. This due to this charge difference. Okay, due to this charge difference, electron has a attraction to this nucleus. Okay, but when increase the energy level, energy levels when increase the energy level, think if we think this is the first energy level, second energy level, third energy level, fifth energy level, sixth energy level, increase the energy level, what happened? The distance from the nucleus is increased. Distance එක වැඩි වෙනවා. Due to this distance, what happened to this attraction? Attraction power is decreasing. මෙයාලගේ තියෙන මේ attraction power, electron attraction power is decreasing. This attraction is decreasing. Therefore, sometimes some part of electrons, some number of electrons, they release this nucleus and they convert into free electrons. If you got copper has more free electrons. If you got aluminium, lot of metals, they have lot of free electrons. Free electrons mean in molecules, due to high distance, so far considerable distance from the nucleus, they convert into free electrons. Free electrons mean their attraction is very low. Therefore, that we called as a free electrons. Free electron. I got the point? We called as free electron. Free electrons. Free electron. I got the point, Dihini? due to this less attraction with higher distance from the nucleus, they be called as free electrons. Free electrons. Are you clear up to now? Okay, now for example, think about copper. Now copper is a powerful conductor, no? Copper is a powerful conductor in your home wiring system. In your home wiring system, what we used? Conductors. Wires විදිහට අපි මොනවද ගන්නෙ? Copper wires, no? Copper wires. What is the reason? They have highly ability of electric conductors, current transformation. Okay, now think this is a copper conductor, copper wire, copper cable, and this copper is a powerful conductor, therefore it has huge amount of free electrons. Free electrons mean they don't have attraction to the nucleus. They are no freely available nucleus, freely moving electrons. Okay, these free electrons locate in this conductor, this cable. They are the free electrons. The huge amount of free electrons in copper wire. Okay, they are the free electron. Okay, if we think normal conductor like this, wait, I will show you. Okay, if we think about normal conductor like this, cable, copper cable, if we got, their free electrons are randomly moving like this. They are randomly moving. Randomly moving means these electrons move into this direction. This is moving to this direction. This is moving to this direction. Moving to this direction. These free electrons don't have, due to this molecule kinetic energy, you know, molecules are always vibrating. Due to this vibration, these free electrons also randomly moving. There is no any specific directions for moving. Okay, this is a very simple story. Okay, you don't need any basic knowledge. Try to understand this story, then you can understand what is the meaning of the electric current, and that's the foundation, that's a basic structure for electricity lesson. No need any basic knowledge. Okay, try to understand this story. Okay, this simple story. Okay, but what I explained, okay, I will explain again. All molecules are made of electrons, protons, and neutrons. No, nucleus is made by protons and neutrons. Due to that, the nucleus is positive charge. Orbitals or energy levels contain electrons. These electrons are negative charge. Nucleus is positive charge. Due to this negative and positive charge, electrons has attraction to this nucleus. Electron has an attraction to this nucleus. Attraction එකක් තියෙනවා. But when increase the distance from the nucleus, when increase the energy levels, what happened? The distance is increasing. Due to this distance, this attraction is breaking. This attraction is decreasing. Due to this less attraction, they convert into free electrons. They are the very important for formation of electric current. Okay, these free electrons are the very important carriers for electric current. Free electrons. Okay, very simple story. Okay, now, okay, try to understand this full story, then tomorrow you can get the tute and read and complete everything. Okay, now these free electrons, if there are no any potential difference mean it don't have connected to a battery. Yeah, battery connect කරලා නැති වෙලාවේදී. Okay, they are randomly moving. There is no any specific directions, randomly moving. Don't know, we don't know what is the specific direction. They are randomly moving. This one moving to this direction. මෙයා මෙහෙ යනවා. Due to different attractions, they are randomly moving. Don't have specific direction. Randomly moving. Randomly moving. If there are no any potential difference, no any potential difference mean it don't have connected to a battery. Okay, normal this type conductor wire. Its free electrons are freely moving, randomly moving. No any specific direction. Okay, up to now, okay. Simple story. Okay, free electrons are randomly moving. Up to now, clear? Up to now, clear? Fatima? Very important, eh? This basic knowledge, very important. Okay, they are randomly moving. If there are no any potential difference. Potential difference එකක් නැහැ කියලා කියන්නේ normal conductor like this. There is no any potential difference, same potential value. Both sides same potential value. Free electrons are freely moving, randomly moving. No specific directions for moving. But if this conductor, if this wire, if I connected to a wait, the same conductor, okay, the same conductor, if I connected to a potential difference mean plus potential and minus potential, the same conductor, same wire. If I connected to the battery like this is a battery 1.5 or any type, I connect this conductor in this battery like this. Now this side get a positive potential. This is positive potential because battery positive direction, positive potential. The left end of the conductor, this end take positive potential. The opposite side get the negative potential due to the battery direction. If you want, we can change the battery direction and change the potential direction, no issue. Now according to the diagram, this end get positive potential and right side get the negative potential. Okay, now Now, now, due to this potential difference, what do you think? What do you think? What happened to these free electrons? Are they still moving randomly, or are they moving to left side direction or right side direction? Any idea? However, it is not again randomly moving. Okay, due to this potential difference, electrons try to move into single direction. Tell me, electrons moving into positive direction or negative direction? According to your basic knowledge, send your answer. Electrons කොහෙටද යන්නේ? Very good. Fatima, Dehini, what is the direction of electron movement? Are they moving to positive side direction or negative side? What do you think? Dehini, are they moving to positive side direction or negative side direction? No, no, no. Rehilan wrong. Dehini wrong. Electrons, what is the charge of electrons? Joel, what do you think? Electrons move into positive charge direction or negative charge direction? What do you think? Yes, good. What is it? That's very simple thing. What is the charge of electrons? Electrons are negative charge. No, electrons are negative charge. They are negative charge. Electrons, free electrons or non-free electron, whatever, they are negative charge. They are negative charge. Now, when I connect a battery or potential difference, this is a negative charge, this is a positive charge. Are they moving to negative? No. They always attract to the positive side. Always negative charge always attract to the positive charge. Not for negative. Negative charge always attract to the positive direction. Okay, therefore all electrons, all free electrons try to move into this direction, into a single direction. Into single direction. Are you clear? Prehlan? Dehini? They try to move into a single direction. It is negative to positive. Negative to positive. This is the direction. This is the direction. Negative to positive. This is the direction. Are you clear, Dehini? That we called as, okay. Now this direction we called as electron current direction. It is not the electric current direction. It is electron direction or electric current that we called as electric direction or electron direction, electron current direction, no? Electron current direction. Electron direction that we called as electron direction. Electrons always transfer from negative charge to positive charge, negative to positive. Is it electric current direction? No, it is not the electric current direction. Always remember, electric current is formed to the opposite direction of the electron direction. The electric current I, the electric current is the I, the electric current formed to the opposite direction of the electron direction, that we called as the current direction. Always current is forming from positive charge to negative charge direction, positive to negative direction. In this conductor, the current, electric current is formed from positive to negative current direction. The electric current direction, always remember, it is opposite to the electron direction. This is the electron direction. The electric current direction is positive to the free electron direction. Okay, this is the basic story. Okay, I will summarize again. I told all molecules are made up of electron, proton, and neutrons. Proton and neutrons present in the nucleus, and orbitals contain energy levels contain electrons. Due to this positive to negative attraction, they have attraction, but when increase the distance from this nucleus, when increase the energy level, they convert to free electrons. These free electrons are the main compounds, main elements important for formation of electric current. These free electrons are the basic compounds for electric current, formation of electric current. If we got this type normal conductor, they are free electrons are randomly moving, but when I connect into a battery, one side take positive potential and opposite side get negative potential, then it has a potential difference. These free electrons try to move into positive charge direction due to positive potential due to the attraction, that we called as electron direction. The electric current is formed to the opposite direction of the electron direction. Okay, therefore always electric current is formed from positive to negative direction. Positive to negative. Electric current from positive to negative always. Positive charge to negative. Okay. Okay, this is your tute. I have clearly given the whole story I explained. This is free electrons. They are randomly moving. They are atoms and free electrons. They are randomly moving due to the vibration of these atoms. Randomly moving, no specific direction. But when I connect the battery into this conductor, what happened? One side get positive potential and opposite side get negative potential. Therefore, these free electrons try to move into positive direction. Free electrons try to move into a single direction. It is positive direction. What is the reason? Electrons are negative charge. They always has attraction to positive potential. That's the reason. They try to attract into positive direction. The opposite direction of the electron movement direction we called as the current direction. This is the electric current direction. It is from positive to negative direction. Always electric charge. See, electric current flow in the conductor in opposite direction of the direction which electrons are moving. It is opposite to the electron moving direction. Okay, this is the basic story of the electricity. Any doubt you can ask. If you have any doubt, I can give you 2 minutes. Potential, there is electric potential energy. Okay, no doubts. Rehlan? No doubt, right? Fatima? Okay, let's move into few visuals.
Your hair damaged? It needs to be refilled with protein.
You might recognize this, an atom, often depicted with electrons swirling around a central nucleus. This is known as the Bohr model. However, modern science has shown us that this is a simplified representation. In reality, electrons exist in more of a cloud around the nucleus, their exact positions defined by probabilities. But for today's...
Okay, this is the nucleus and they are the orbitals. Electrons are moving along the orbital and they have attraction. See this
discussion. Let's stick with the Bohr model. It's a bit more visually straightforward and serves our purpose here. Now, let's focus on this tiny particle, the electron. It's this electron, with its inherent charge, that plays a starring role in the phenomenon we call
negatively charged.
When these electrons move, they create what we experience as electric current.
Yes, this is the electron direction. Always electrons moving from negative to positive direction. Oh, what happened?
You might recognize this, an atom, often depicted with electrons swirling around a central nucleus. This is known as the Bohr model. On the nucleus, their atomic structure is such that they have what we can visualize as a sea of free-moving electrons. While metals are good conductors due to this sea, other materials like rubber resist the movement of electrons. These are called insulators.
Okay, that part we can discuss. Insulated mean they are insulators mean normal conductors mean they have a lot of free electrons like copper, aluminium. They have huge amount of free electrons. Insulated mean like rubber, plastic. They have a very less amount of free electrons. That's why they are the ability of electric transfer depend on this number of free electrons. Okay, that we can discuss in next part.
1.602 times 10.
Okay, these values I will explain.
When you bring together around 6.242 quintillion of these electrons, their combined charge equals a coulomb. When these coulombs of charge move through materials, such as in the wiring of our homes and devices, we see effects like light bulbs illuminating. This movement of charges over their combined charge equals a coulomb. When these coulombs of charge move through materials, such as in the wiring of our homes and devices, we see effects like light bulbs.
Okay, that's the electric current direction.
Over time, that's electric current. If we were to break it,
they are the electrons. Always electrons. This bulb is function due to these electrons go through this bulb. Okay, we can discuss later these basic parts. Okay, this is a negative potential. It is positive potential. This is a battery. Always electrons transfer from negative to positive. Negative to positive. The current flow into positive to negative.
Now mathematically, current, represented as I, is the charge.
Okay, these equations we can discuss later.
It takes. So a current of 1 ampere means 1 coulomb of charge flows every second. Before we move on, there's a
see the direction. Okay.
When we talk about the flow of electrons, they actually move from the negative terminal to the positive terminal.
Negative to positive.
Historically, the conventional current was defined as moving from positive.
This is the current direction.
This was set before we understood electron flow. So
okay, clearly understand the direction. Okay, this is the electron current. Electron current direction. What is the electron current direction? Negative to positive. electron is always moving negative to positive. The current, electric current is moving positive to negative. හරියට බලන්න.
Was said before we understood electron flow. So in most diagrams and textbooks, you'll see current represented as flowing from positive to negative. But remember, electrons themselves move in the opposite direction. It's a quirk of history we still observe today. From charging our phones to powering entire cities, this flow of electrons, this current, is fundamental to the world we know. So the next time you flip a switch or marvel at a device coming to life, remember the incredible.
Over the years, humans have come to understand, well, the four fundamental forces of our universe. Like gravitational force, the electric force plays an important role in our everyday life. With the help of the electric force, we are able to generate and use electricity, which is essential for us in our modern age. But what is electricity? How does it work? What is the difference between current and voltage? We already know that everything is made up of atoms. Atoms are very, very tiny. A copper penny would have nearly 3.2 into 10 to the power of 22 copper atoms inside. However, even the atoms aren't small enough to explain the workings of electricity. We need to dive deeper to the center of the atom. Here, the center is called the nucleus. It is made up of particles called protons and neutrons. Nuclei contain one or more protons and usually an equal number of neutrons.
It's explain the full story very simple level with graphic. Again, try to get
There are
full
also electrons in orbit
understand.
around the nucleus. Protons have a positive charge. Electrons have a negative charge, while neutrons have no charge. The number of protons determines the kind of atom or element. For example, if an atom contains one proton, then it's hydrogen. If it has 6 protons, then it's a carbon atom. The number of protons is called the atomic number of an atom.
They are all level
In a
things.
stable atom, the number of electrons is equal to the number of protons. So their charges cancel each other out and result in the atom becoming neutral and stable. If the number of protons...
Okay, I think these things you can remember. A number of protons and electrons same. The overall atom is a neutral. But this time protons 7 and 6 electrons. Now it is positive charge. No? They are all level
greater than the number of electrons. The atom is called a positively charged atom.
positively charged atom.
Similarly, if the number of electrons is greater than the number of protons,
Electrons
the atom is
greater.
only negatively
Now it
charged
is
atom. We call both positively and negatively charged atoms ionized atoms, because the same charges repel each other and opposite charges attract each other. Negatively charged electrons...
But you can't hear? Video sound, oh my sound. Abi. Now okay. Joel, is there an issue with sounds? Dihini? You can hear, right? I think no issue. Amina? Can hear, yes.
call both positively
Negative-
and negatively charged
negatively
atoms
charged.
ionized atoms. Because the same charges repel each other and opposite charges attract each other. Negatively charged electrons orbit positively charged protons. Electrons orbit the nucleus, but at different energy levels, also known as shells. The shell
They are
closest
shells
to the
or
nucleus
orbitals.
can hold 2 electrons. Next shell can hold up to 8 electrons, and outer shells can hold even more.
That we
The
discussed.
amount of force acting on 2 charges depends on how far they are from each other. The closer 2 charges get, the greater the force becomes.
Yeah.
The electron,
Okay, this is a point. Okay.
even more.
That
The
this is
amount
the,
of
I
force
explained.
acting on 2 charges.
Now, high distance, low force. Low force means less attraction. Low force. See
depends
clearly
on how far they are from each other.
when they
The closer
come,
2 charges get, the greater the force becomes.
force means they
The
have more
electrons in
attraction.
The shells closest to the nucleus have a strong force of attraction to the protons in the center.
Yeah.
The electrons in the outermost shell can't easily hold their.
Yeah. This is, I think you have full idea now. This is a high attraction, medium, low, very low. Okay.
Position due to the distance from the center. These electrons are called valence electrons.
Valence
These valence
electron.
electrons
Now you got new term. Okay. Free electrons or valence electrons. Okay. Valence electrons, free electrons can same.
can be easily pushed out of their shell when enough force is applied. This is how electrons jump from one atom to another. These moving electrons are what we call electricity. Atoms sharing their electrons between one another create electricity. In simple terms, moving charged particles creates electricity. That means electrons have an electric field. And when electrons move, electricity is created. If we look at the copper atom, it has one valence electron. And if we look at the silver atom, it also has a valence electron. So from these atoms, we can easily remove electrons with enough force. These materials are called conductors. Most of the metals
Conductors.
are conductors, but some materials hold their electrons very tightly, and they don't share their electrons with nearby atoms. Those are called insulators.
Insulator.
Serve a
See?
very
I got the difference. Insulators mean don't have valence electrons. Don't have, actually, very limited, very less valence, very less free electrons. We called as insulated, but conductors, see, conductors, they have
materials hold their electrons very tightly, and they don't share atoms. We can easily
See?
remove electrons with
They
enough
have
force.
free
These materials
electrons.
are called conductors. Most of the metals are conductors, but some materials hold their electrons very tightly,
very
and
tight.
they don't share their electrons with nearby atoms. Those are called insulators. Insulators serve a very important purpose. They prevent the flow of
No
electrons.
space, right?
For example, plastic, rubber, and glass are made up
They are
of
the
these types
insulators.
of atoms. How can we move electrons from one place to another? It is not a complicated thing. When we rub 2 objects, electrons will be transferred from one to another. In some cases, you don't even need to rub 2 objects. Sometimes even simpler contact between 2 different materials is enough to transfer electrons. For example, when you walk across the carpet, electrons transfer from your body to the carpet. As a result, you have an absence of electrons in your body. Nature is always trying to maintain a stable state. So your body then looks to find electrons. Carpet is a good insulator, so you can't get
Insulate.
electrons from that. When you touch a metal, your body gains electrons from the metal. In that scenario, you feel a little shock in your hand, because electrons moving to your hand from the metal create electricity. Now we look into a simple electric circuit with a battery. Here the battery is
Okay, this part I will explain. Our next part, this is about electric charge. Electric charge part I will explain. This part I will explain and again show you a visual. Okay, now understand
Here the battery
directions.
is- battery has an excess of electrons and the other side does not. Inside the battery, an insulator facilitates the separation of electrons through chemical reactions. So here, electrons from the battery move through nearby atoms. Those nearby atoms should contain valence electrons. As we have seen before, copper atoms are good conductors, which contain valence electrons. So we normally use copper wires as a conductor. Electrons come from the battery, pushing the copper atoms' electrons.
This is the electron
So
direction,
electrons flowing
positive.
in the wire in the same general direction create electricity. The movement of electrons from atom to atom is the same everywhere along the wire. The distribution does not change as the electrons move. When you disconnect the battery, each atom is left with its proper number of electrons. The number of electrons that came out of the wire at the negative terminal is exactly equal to the number that entered the wire at the positive terminal. Only electrons can move if their circuit is closed. If it's open, electrons can't move, and so no electricity. If we place a light bulb between the closed circuit, the bulb starts glowing. But how does it glow? Normally, a bulb has a thin filament made of tungsten. Even though tungsten is a conductor, it has some resistance. The long, thin, twisting path creates an electric resistance and affects the flow.
Okay, that's how a bulb is glowing due to these electrons moving through the filament.
Electrons. So the electrons cannot freely move between atoms. Atoms in the tungsten start vibrating, heating up the tungsten, and as a result, it begins to provide light and glow. We heard the word current. So what is electric current? A simple small copper wire contains trillions and trillions of electrons. In a complete closed circuit, electrons moving from one to another direction. If we look at a single point, we can calculate the number of electrons passing through this point per second. Current is measured in amperes. 1 ampere is equal to 1 coulomb. The rate that electrons move through a conductor is beyond the ability of the human mind to imagine. 1 coulomb of electrons means 6.28 billion electrons, or 6.28 into 10 to the power of 18
Don't think about this value. So
electrons flowing past a given point in 1 second. So the 1 ampere is the number of electrons passing through a point in 1 second. It means the number of electrons that pass a given point in this conductor in just 1 billionth of a second is greater than the total number of people living on Earth today. This calculation is similar to the flow of water. We can calculate how many liters of water pass through a particular point in 1 minute. So electric current means nothing but flow. It is the rate at which electrons flow past a point in a complete electric circuit. Now we understand how electrons can flow, but how do we get them flowing in the first place? That's what batteries or generators do. They push the first electrons. That push is called voltage. In a battery, one end has an excess of electrons, while all of the positive charges are on the other side. So there is an energy difference between 2 points called the electric potential difference.
electric
So what
potential
exactly is
difference.
the electric potential difference? Let's consider a motionless ball of the surface of the Earth. This ball is at rest, so its potential energy is 0. If we want to move the ball directly upward, we need to provide some energy against the gravitational force acting to pull the ball down to Earth, because gravity is always pulling objects on Earth down. So we provide some energy to push the ball up into the air, and the ball will get some potential energy.
That you already
So the
know.
ball above the surface has high potential energy, considering it has 5 joules. So we calculate the difference between the 2 balls' potential energy. The potential difference will be 5 joules. This is called gravitational potential difference. Now we come to
Okay, this potential difference and voltage things for your additional knowledge. Again, we discuss these points one by one. Okay, now get a simple idea.
electric potential. Similar to gravitational potential, there is electric potential energy between 2 charged particles. In terms of gravity, 2 objects always attract each other. But in terms of electric force, equally charged particles repel each other, and oppositely charged particles attract each other. So here, positive and negative charged particles stick together due to the electric force. Now we need to do some work against the electric force to move the negative particle away from the positive particle. For any charge located in an electric field, its electric potential energy depends on the type of charge, amount of charge, and its position in the field. So here, consider the potential energy of one end is 2, which is in its lowest potential state, and the other end has a high potential state of 3.5. So the potential difference between 2 points is 1.5 joules per coulomb, or simply 1.5 volts. So charges are always trying to equal the potential energy difference. In a 1.5 volt battery, the electric potential difference between 2 points is 1.5. When we connect a copper wire to a battery, because of electric potential difference, electrons are pushed by the negative terminal and pulled by the positive terminal. The electrons in the copper will move from one atom to atom, creating a flow of charge we know as electricity. The battery will dry out when the potential difference between 2 points becomes 0. The flow of electric current is dependent on voltage. This means that increasing the voltage will cause the current to increase. The less voltage, the less current. The more voltage, the more current. If we connect a 100-volt battery in a simple small wire, push of the electrons is very high. The atoms inside the wire are not able to carry the flow of so many electrons, so atoms start vibrating. The wire will heat up, causing damage or fire. That's why we use wire with the appropriate thickness, depending on voltage. Even though we
Okay, this thickness things that we called as current density, that's the new part of the lesson.
humans are well trained about how to handle electric force on a
Okay,
global
that enough.
level.
Okay, I got any full idea or any doubt? You can ask now. Any doubt? No, right? Okay. Okay, our next topic is the drift velocity. Drift velocity. Okay, normally this drift velocity mean I told these free electrons are randomly moving, or when I connect a potential difference, what happened? They are moving to a single direction, negative to positive direction. Now this moving speed, these electrons moving this speed of the conductor, free electrons, valence electron moving distance of the conductor, we called as the drift velocity. Drift velocity. These free electrons moving this speed. They are kochara speed that we called as the drift velocity for your information. Okay. Okay, this is the relationship between electric current and charge. Charge and electric current. Okay, this is a very simple experiment. Okay, we can get ebonite rod. Ebonite rod mean normally we can get very shiny whatever rod. Okay, now ebonite rod and hold the ebonite rod and one hand and hold the neon bulb. Okay, before that we have to rub this ebonite rod with wooden cloth. Okay, that's you can practice this experiment. Okay, let me try to show you this. Okay, it is not a rod, it is a plastic pen. Okay, the same thing you can get the observation using this pen as well. Okay, now I have a paper and this plastic pen. I'm going to rub this pen by this paper. By this paper. Okay, now, but the problem is now today I don't have LDD. It's not working. Okay, let's do it next day. No? Okay, you can rub this rod by your hand or using cloth, and when it is after few minutes you can touch a LED bulb. Then it is very few milliseconds, not actually think very few time, very small time, it's glowing this bulb. What is the reason? Due to this rubbing, a charge is due to this electric push. Force due to this force, free electrons forming of the ebonite rod. Due to that, these free electrons moving through our bulb, very small time it's glowing. It's not continuous glowing, it's very small time. Touch the other end of the neon bulb to the rod and observe the bulb lighting up. You can get clearly observation by performing this experiment in dark room. Dark room mean in dark condition. If you can conduct this experiment, you can get proper observations. Okay, I'll show you.
Wikipedia Pro School Champs. Alle Blöcke checken.
Today, I'm talking about charge and current. To understand electricity, we've got to know a little bit about atoms. Atoms are these tiny little particles that make up air. Now, the neutrons or neutral, they've got no charge. Might be able to move from atom to atom within the material. They might also be able to move. Turn, we can see the stream of water is moving towards the comb. The reason for that is, as we rubbed the comb against the cloth, we were transferring electrons from the cloth to the comb.
Yeah.
It's giving a collection
you
of
can
negative electrons, which means the comb is becoming negatively charged. Similarly, because the cloth is losing electrons, it is becoming positively charged. This is what we mean by charge. Because the comb is negatively charged and place it next to water, which is polar, meaning it has positive and negative sides to its molecules, the positive parts are attracted to the negative charge of the comb, and so the water stream is attracted to the comb. Now, as I mentioned, electrons can flow from atom to atom within some materials. It's this flow of electrons that allows electricity to be transferred. This flow of electrons is what a current is. Some materials allow these electrons to be moved a lot easier than others. Metals are materials that generally allow electrons to move quite easily, and that's why metals make very good conductors of electricity.
Okay,
But we know that electricity is a flow that creates a collection of electronegative or allows very convenient to talk about the. We don't usually say amperes, it's more common to say amps, and it's given the symbol A.
Okay, that's how by rubbing or something applying a pressure or by force, we can make free electrons. We can increase the number of free electrons of any substance. Okay, in this conductor experiment, we can we can push by potential difference. Even without potential difference, we can get electric charge by rubbing or whatever external force. The force we can get this charge. Okay, this is a simple. However, these electrons are moving negative to positive direction. The electric current is moving positive to negative direction, opposite direction of the electron movement. In the experiment, the ebonite rod was charged by rubbing it with a woolen cloth, and the charge passed through the neon bulb. The generate electrons pass through the neon bulb. Can be concluded from the above experiment, an electric current is generated by the flow of charge. Okay, that's our conclusion. The electric charge is always formed by the electron movements or charge movement. Electric current is generated by the flow of charge. Flow of charge means flow of electrons. Charge moving by electrons. The electric current is always generated by flow of charge, flow of electrons. Okay, any doubt up to now? Now our basic story is completed. Now we have conclusion. Always electric current is flowing due to the charge flowing. This charge is flow by electron movements. Understood? You mean to Amina? Okay. As I explained in previous part, according to the number of free electrons or valence electrons, we can divide substance into three types. We can divide substance into three types according to the number of free electrons: conductors, semiconductors, and insulators. Conductors, semiconductors, and insulators. Okay, what are the meaning of conductors? Conductors mean usually very large number of free electrons that we already discussed, no? Very large number of free electrons. Normally it is greater than 10 to the power 15 per cubic centimeter. Okay, think this value. What is the meaning of cubic centimeter? Cubic centimeter means 1 centimeter, 1 centimeter, 1 centimeter length, 1 centimeter height, 1 centimeter width, box, no? Cube. Within this small cube, 10 to the power 15. 10 to the power 15 means 10 and 15 0. That much of free electrons. That's why we call as it's a huge number. Okay. And the temperature change that we can discuss in the temperature part. Okay, I will explain now if you want. When temperature increases, the number of electrons, what happened to this number of electrons? Due to high temperature. Normally I ask, when increase the temperature of the conductor, think your home copper wire temperature is increasing. Temperature increasing, what happened to these free electrons? Remember, in conductors like copper, aluminium, like conductors, with temperature, these free electrons are decreasing. Free electrons are decreasing. That I can explain reasons for that in the temperature part. Therefore, with temperature, the conductivity is decreasing. Okay. A conductor such as copper has 10 to the power 23 per cubic centimeter, see, of free electrons. Example, silver, copper, gold, aluminium, iron, steel, mercury, brass, graphite, impure water. Impure water means okay, if I ask drinking water, conductor or insulator? Drinking water, conductor or insulator? Api normal water, drinking water. Natural water, I ask natural water, conductors or insulator? Fatima? Dehini? Red lamp? Drinking water? Yes, drinking water conductor. Drinking water conductors. Drinking water conductors. Normally, impure water mean including drinking water. Insulator example, you can see pure water. Pure water mean, see, pure water mean deionized water. Deionized mean no any iron, no any minerals in the water. Okay, normally normal water, natural waters are water conductor. Concrete, salt solutions, salts mean minerals. Acid solutions, they are good conductors. Okay, semiconductor. Okay, before semiconductors, I will explain about insulators. Insulators mean they have very less amount. They have free electrons, but it is very low amount. Typically, they are between 0 to 10 to the power 3. Maximum 10 to the power 3. That means 1000. Maximum 1000 of free electrons. It does not conduct electricity because they have less free electrons. The number of free electrons does not change with temperature. With temperature, it is not more effect. Glass, rubber, oil, fiberglass, porcelain, dry wood. What is the reason for dry wood? How about wet wood? Wet wood, they are conductors. Okay, wet wood can with water. Normally, I told natural water is a conductor. Then wet wood is conductor. Bakelite is a polymer. Paper, air, and polythene plastic, including, they are insulators. What is the reason? The number of free electrons very less. Okay, there is another very special type of conductor that we call as semiconductor. Semiconductor means between conductors and semiconductors. Usually they have medium level of free electrons, 10 to the power 5 to 10 to the power 10 per cubic centimeter. When heating semiconductors, okay, this is a special point. When heating semiconductors, the number of free electrons increasing. Okay, that we can discuss in the next lesson. With heat, with temperature, the number of free electrons increasing. Then the conductivity is increasing. Silicon semiconductor has, silicon is a semiconductor. Silicon is example. 10 to the power 9 per cubic centimeter free electrons. Okay, silicon, germanium, gallium arsenide and copper oxide, gallium arsenide, copper oxide, silicon, germanium, they are semiconductors. Remember, semiconductors, what are the examples? Silicon, germanium, gallium arsenide, copper oxide. They have medium level of free electrons. That's why we called as their conductivity is medium. That's why. But with temperature, we can increase the conductivity. Okay, that we can discuss in the next part. Semiconductors mean medium level conductors. Remember? Understood? Okay. Okay, now we'll move into our next part. What is the meaning of electric current? Now we already know the story, basic story. Okay, electric current, remember the electric current symbol capital I. The capital I is the symbol, not C. Okay, capital I is the symbol for electric current. Okay, as we discussed in the previous video, what is the definition of electric current? Electric current mean, it is very simple. If we got this type conductor, okay, think it is a conductor wire. It's a conductor wire. A conductor wire. Conductor wire. Okay, if you got, if I connect a potential difference, that means battery, within 1 second, the electron or charge flowing if you got this one point, think whatever any cross section, within 1 second or within unit time, how much electrons are flowing, how much charge is flowing, that we called as a current. Or in other word, in other form, we can explain the rate of flowing electric charge, or the electric charge flowing in a unit time, that we called as the electric current. The rate of flow of electric charge, the rate of flow of electric charge through a cross section of a conductor. Or in other word, the amount of charge that has passes through any cross section in a unit time, that we called as the current, electric current. Okay, according to this relationship, according to this meaning, we can get the electric current equal the total free charge moving through the conductor divided by the time taken for this process. Time taken. Then in short form, we can say the I equal Q over T. Q mean the charge flowing amount divided by time. Okay, this is the first equation of the lesson. I equal Q over T. What is the meaning of Q? It's charge. The amount of charge divided by time. Don't mislead with the heat lesson. In heat lesson, Q mean quantity of heat. No? Okay, but in electricity, Q mean the amount of charge. The current equal the amount of charge divided by time. The amount of charge flowing through any cross section in a unit time. In a unit time, we can calculate by dividing by time. I equal Q over T. 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 Okay, what is the unit of current? What is the unit of the current? Joel, what's the unit of the current? What's the unit? Rehlan, what's the unit of current? Yes. Actually, the actual unit is the Q mean the amount of charge, no? The amount of charge, see it is given. I equal Q over T. The amount of charge, the unit is coulombs. Coulombs, simple C. Coulombs is the unit of charge. Divide by time standard unit seconds. Actually, the coulombs per second is the unit. CS minus 1 is the unit. CS minus 1 coulombs per second is the unit. Coulombs per second is the unit. But for respect for the scientist who found this theory and this electrons movement and everything theory, we consider the standard unit, derived SI unit of the current, it is ampere. Ampere. Ampere is a scientist. Okay. Ampere is a scientist name. Okay. Coulombs per second we consider as derived SI unit, it's ampere. Okay, good point. I got. Okay, up to now any issue that's basic part of the electricity is completed. Okay, I fully explained without any part missing. I fully explained the basic part of the electricity. If you have any doubt, you can ask now. Tehlan, everything clear? Fatima, Dihini, Amina. Okay, good. Okay, this is the final topic of today. Today I told we're not going to discuss advanced things. What is the target of today class? Complete the basic part of electricity. Okay, the basic part sama pikaranne. Without tunes, you can understand these stories. Tomorrow, everyone, you can get the tune tomorrow. If not, you can check your post office. Okay, after you got the tune, you can read and complete these points. Okay, the final topic of today, the basic part, the current density. Current density. Okay, before moving to current density, do you know what is the yeah, before that come to this, give me a second, come to this experiment. Okay, okay, this is my phone charger. This is my phone charger. Get the thickness, get some idea about the thickness of the this wire conductor thickness, and this is my laptop charge. This is the laptop charge. This is the laptop charge. This is the laptop charge. How about the thickness of these two conductors? See, get some idea why laptop charger is high thickness, greater thickness than phone charger thickness. Anyone? What is the reason? What is the reason? Actually, previous video they already explained, right? the reason current density. Okay, do you know where you can find the greatest thickness conductor in your home wiring system? ගෙදර wiring system එකේ කොහෙද greatest thickness wire is located? Now engineer technology, you're doing wiring systems, no? කොහෙද තියෙන්නේ? If not, how about the thickness of normal transmission wires, transmission conductors in roads, the transmission conductors? How about the thickness? They are greater thickness, no? More than our house wirings. Normal conductors, they are greater thickness. Greater thickness. Okay, now first in our home wiring system, this transmission wire come to our meter panel. Meter panel. ඊට පස්සේ කොහෙද දෙන්නේ? This is a transmission. No? What is the next point? This is transmission. Transmission. Think this is our house. Oh. Now this is our current wire. Current wire. This is our current wire. They are transmission wires. How about the thickness of transmission wires? Greater thickness, no? Greater thickness. Okay, this is our transmission wire. We got into our home. Then the same wire, the white color wire. No, green color is the wire, our transmission wire. Okay, now this is the wire. And this is our meter panel, meter board. Okay, it's still the thickness is same. Thickness is same. Okay, what is this transmission wire material? Are they copper or aluminum or silver or what? Transmission wires හදලා තියෙන්නේ මොනවා වගේ? Sarmia? Transmission wires කියලා කියන්නේ ඔය මේ පාර තියෙන කබේ. Transmission wires. Yes, they are aluminium wires. They are aluminium. Okay, normally if you got aluminium and copper, the conductivity ability is greater in copper. But the main problem in copper, the copper price is greater. Copper very expensive. For this type transmission, we can't use. Their conductivity ability is greater, but we can't use for transmission process. We need large quantities for transmission. It is highly expensive. Highly expensive. But if we got aluminium, the price is less. Aluminium less expensive, but transmission ability less than copper. But however, for transmission, we use aluminium. Aluminium තමයි use කරන්නේ for transmission. Aluminium. Okay, now aluminium තමයි up to meter board. It's an aluminium conductor. Okay, after meter board, electricity board only provide current up to this level. Okay, then our wiring system is starting. Our house wiring system is starting from meter board. Okay, then this is the dividing panel in your house, inside your house. Inside your house, dividing panels can tip switch available part panel. Okay, tip switch and main switch and fuses available panel. Okay, this is the more thickness conductor in your wiring system. When මේ wire එක තමයි create a thickness. It is a copper wire. It is a copper wire. The thickness of this wire, this conductor is greater than other wires. What is the reason? What can be the reason? Anyone? If you got other distributors, they are same normal conductors, normal copper wires. Normal copper wires. But the thickness of this meter panel to dividing panel, it's greater. What is the reason? You can check in your home. How about thickness of meter panel to dividing panel wire? And how about thickness of your normal wiring system? They are normal wires, but this is highly thickness one. What is the reason? Remember, the reason is the current density. The current density is the reason. Okay, now let's move into current density to understand this thing. Okay, current density is the electric current flowing perpendicular to the unit cross section of the conductor. Current density is, this is the current density. This is the current density. Current density we call as tau. It's not J, it's tau. Okay, tau. In rotational motion lesson, tau we use for torque. In physics, maybe the same symbol used for different quantities. Okay, tau is the current density. The current density equal the amount of current flowing through unit cross section. The amount of current flowing through unit cross section. The amount of current flowing through unit cross section. Okay, now understand what is the unit of current density? What is the unit of current density? Okay, tell me what is the unit of current density? See, this is the current density. Anyone? Quickly. What is the unit of current density? Fatima? You may know? What's the unit? The current density means the amount of current, the amount of electric current flowing through unit cross section area of conductor. Unit cross section area. Then the tau equal, tau mean current density, current divided by the cross section area. Current divided by cross section area. Okay, send me what is the unit of the current density? Very good. Current standard unit ampere. Cross section area as standard unit square meter. AM minus 2 amperes per square centimeter. Amperes per square centimeter is the unit of torque. This is the torque unit, current density unit. This is a current density unit. Okay, however, it is very simple equation. Okay, now current density. Okay, now tell me, according to this relationship, when increase the current increase, when increase the electric current flowing through the conductor, what happened to the current density? It is directly proportional, remember. According to this relationship, when increase the current flowing through a conductor, the current density is increasing. But when increase the cross section area, current density is decreasing. It is inverse proportion. This current density directly proportional to the current and inversely proportional to the cross section area. Okay, then can you understand, when I increase the thickness of when I increase the cross section area, that means thickness of the conductor, the current density we can minimize. We can reduce the current density by increasing the thickness. Increasing thickness, the current density decreasing. Are you got the point? Okay, now in our previous example, the meter panel to dividing panel conductor is highly thickness. What is the reason? The full current is flowing. The transmission to full current is flowing up to this. Then in divider, it's divided into 10 ampere, 15 ampere plugs and bulbs. But in fuse box, it's doing by fuse box. Up to fuse box, this conductor, this line, it's throwing huge ampere value. That's why to reduce the current density, to reduce torque, it's increase the cross section area, increase the thickness. I explain my phone and laptop chargers. You know, laptop charger required more current than phone. That's why for phone, this thickness is enough. But if you're going to charge my laptop by this type cable, what happened? Actually, what happened? If I going to charge my laptop by this type cable, may size के cable लेके, what happened? Habib, any idea? What happened? Oh, මේ size cable එකක් දානවා මෙතෙන්ට. What happened? Yes, the cable is burning. The cable is burning. They can't, they don't have capacity to retain. Burn වෙනවා. Over capacity වුණොත් burn වෙනවා කියලා දන්නවනේ. The same, what is the reason? Now you know the reason. The reason is current density. How we can minimize this burning? We can increase the thickness of this cable. Thickness එක වැඩි කරලා we can reduce the air density. So not air density, current density. So I think you got the full idea. Okay. See, the same current is flowing through this type conductor. Okay, the same current I is flowing. Now you can understand, at this level the thickness is less, the cross section area is less. How about the air density? The air density is greater than, not air density, current density. Current density is greater in this n. Okay, this is the basic relationship. The rho equal current density inversely proportional to the cross section area. Therefore, we can increase the cross section area to reduce the current density. To reduce the current density by increasing cross section area. According to the cross section area of conductor is inversely proportional to the current density. Inversely proportional to the current density. That means cross section area increasing, current density decreasing. While current flow through a conductor or different cross sections, conductor of different cross sections, the current density changing. Yes, the current density change with cross section area. Accordingly, as the cross section area decrease, the current density increases. Current density increases. Current density increases. Okay, that one also very important for MCQ part. Variation of current density as with cross section area. Okay, with cross section area, it's a inversely proportional. This is the graph shape. Inversely proportional means downward. Okay, this is a directly proportional na mehema. It's inversely proportional. Okay, current density and cross section area. Okay, that's simple thing. The electric current flowing through a closed circuit is measured by using ammeter. This is ammeter. When taking reading from an ammeter, the instrument must be connect series. Okay, this connection method I will explain later. I need to convert. Okay, that's all about basic of the current. Basic of the current. Basic of the current. Okay, that is our today target. That's our today target. Okay, I hope you got full idea of today lesson. Tomorrow you can get the tute of the electricity lesson and all tutorial and activity pack. Okay, you can start tomorrow. Is a new year, no? 2026. Your life very important year, I think. 2026. Okay, before we move into end, do you have any doubt of today part? Okay. Very simply, I explained the full story. It is very basic things today we discussed. Okay, to next week actually we going to discuss the bit advanced parts. Okay, any doubt? I can give you 1 minute. If you have any doubt up to now, current density, current flowing, current direction, current units, drift velocity. No, right? Okay. No doubt. Okay. Okay, this is the end of today's lesson. Okay, actually tomorrow is 1st of January. It's a new year and very important time period of your life. Okay, you have only 6 months. 7th month is exam. Okay, 10th of August your exam starting date. 10th of August. Therefore, it is a very okay, very important for your life, and you have to work very hard during this period, this 6 months of the 2026. Okay, therefore actually take this new year as a new start for your working. And in January month, our revision, we have huge workload. Okay, we have exam and we have part of exam, previous exam also we have to cover force lesson revising not completed yet. After that, we have another weekly paper pack now coming, and not easy, but take it as a new start, and you have to work very, very hard because you have very limited time. Only 6 months you have. Within 6 months, in 3 subjects, the workload is not, it's not a small work. Okay, your workload is very bulk. Therefore, you have to work very, very hard. And consistency, as I told last day, if you want a good result, the consistency and continue working. Everyday working is very important. Everyday working, and every month face an exam, and analyze your month, analyze your marks with previous months, and that's the path. Improve your marks and your result yourself. Okay, actually anyone can't increase your marks now. Within the 6 months, you are the responsible person about your result. Okay, your behaviors, your working time, working patterns, everything, this 6 months depend directly into your result. Okay, therefore 2026 is very important for your life, because exam both coming 2026. Exam August mean end of December you can get your result. Okay, therefore I hope you all can get as a new start from tomorrow, and I hope you all will be very successful year 2026. Okay, that's the end of today's class. Meet with paper discussion. Okay, good night, goodbye.